Okay, so now we're going to talk about something called chain rule. Chain rule is what allows you to take the derivative of a more complicated function. So now you can take the derivative of composite functions, which are like the 3x plus 1 quantity to the 12th or whatever, without having to simplify it into products or quotients or things like that. So chain rule, what it looks like as a rule, is that you're taking the derivative of f of g of x, which is why it's a composite function. What you do is you take the derivative of the outside part without changing the inside, and then you take the derivative of the inside part. When I talk about it, I always sort of compare it, weirdly enough, to like an onion, because you need to deal with it as different layers. So you want to look at it as being layers of the problem. That's what's going to make it easier. So I've got 1, 2, 3, 4, 9 to do. Once you get the hang of it, you kind of notice that they all kind of work out the same way, and that it's similar as to how you approach them. Okay, so we're going to talk about how you take the derivative of them and then how the simplifying works. We're not going to be simplifying a lot. You're only simplifying a tiny, tiny bit, and you're only simplifying when it's simple. Again, you don't need to impress me with your multiplication skills. So, when you're trying to take the derivative of something involving chain rule, what you do is you want to look at it and you want to figure out the biggest thing that's going on. Okay? So, the most complicated aspect of this problem is the fact that you're cubing something. So the cubing is the biggest thing happening. So that is the first thing that you deal with. Because like I said, there are layers. So when you take the derivative of something being cubed, what you do is you do power rule. So you're going to take the power and pull it down. And now your something is being squared. Notice I have changed nothing other than to deal with the power. Okay, so that means I've dealt with the power. I'm done with that. So then you move in a layer and you look at that and you say, well, that's not just x, that's a function. So you need to take the derivative of it. And the derivative of that is going to be 8x plus 7. Now notice, to get here, I started taking the derivative of this piece and then this piece, which meant I was no longer dealing with composite functions. I was dealing with individual terms. Once you start dealing with individual terms, you stop, okay? And notice, when I'm looking at this, I'm looking at the original problem. Don't look at this as you're working on it, because then you're gonna wanna put an 8 here and you'll have made it weird. Go back to the original problem and you're figuring out what to do, okay? So then same thing, once you get here, stop. I don't need to see you square this and distribute and just go wild with it. Leave it. Okay, so here, same thing. The biggest thing that's going on is the square root. So that's something to the 1/2 power. That's the first thing that you need to deal with. So you pull the 1/2 down, and then you have all this stuff to the negative 1/2 power. Well, this was not just an x. It's a composite function, so then you have to take the derivative of that part. That is a quotient. So to take the derivative of a quotient, you have to do quotient rule. So doing quotient rule here, you've got bottom, derivative of top, which is going to be 3, minus top, derivative of bottom, and same thing, since it's just 2x, I wouldn't write it back here. I'd put it here so it doesn't look funny. Over the bottom, squared. And then, and this is super important, leave it, okay? Don't simplify it, just leave it alone. I need to make sure that you can get this far. If you can get this far right, fine, and you can simplify it in the future, okay? But right now, just get there and quit. Okay, so before, when we had just tiny rules, you were forbidden to do quotient rule when you had a constant on the bottom. It's bad. Now you are equally forbidden to do quotient rule when you have a constant on the top. Okay? Because really what this is it's 8 times 3x minus 4 to the negative 5th. And you just have to do power rule and chain as you go, okay? So doing power rule, you pull the negative 5 down, so then you're looking at negative 40 times this to the negative 6th. Then this isn't an individual term, that's a function, so you have to take the derivative of that part, which is 3. And then leave it. You can make this negative 120 if you want, or you can go, I don't want to, and leave it like that. Either one is fine, okay? Because we're not doing anything with them other than finding them, there is no real benefit to making it negative 120. If I had realized it in the beginning and just done it, I would have left it, but I wouldn't go through and rewrite it again. Okay, so same thing. You need to look at it and figure out the biggest thing that's going on. The biggest thing here that's going on is the cubing part. So you say, okay, so I have to take the derivative of thing that is being cubed. Okay, so the derivative of thing being cubed is 3 times thing squared. Okay, so now you've dealt with this. Then you're going to move in a level. And you say, okay, so now the biggest thing going on is the sine of something. Well, the derivative of the sine of something is the cosine of something. So then you're going to have cosine of something, which is 5x plus 2. And you say, well, that was still the derivative of something that was a quantity. So then you have to take the derivative of this part as well. Okay? So the derivative of that part is just 5. Instead of planting a 5 back here, I'm going to squish it together with the 3 and just make it 15. Because it's super easy simplifying. When it's super easy simplifying, I tend to do it because it looks way more awkward if you don't. Okay? Where you need to be careful is that you need to make sure that you're only dealing with one layer at a time. Okay? Notice I pulled the 3 down and left its sign. You don't pull the 3 and make it cosine simultaneously. Okay? Similarly, once I dealt with the 3, you stop messing with it. That's why this wasn't cosine squared, because I'm not looking at this. I'm looking at the original problem, and once the 3 is gone, you deal with your next level of stuff, okay? And then that's going to be your answer. Okay, next one. So here you have these 2 functions that are next to each other, and you have that random 3 in front. Fine. It's a product. You have to do product rule. Okay, so then you do product rule. Again, please don't try and hit them both separately. So product rule, you have first derivative of second. So to take the derivative of the second, I'm going to pull the 3 down with this 3, so really it's a 9. I'm going to have 12x plus 1 squared. Then you take the derivative of 12x plus 1, which is 12, so same thing. Because I'm thinking about it and taking my time as I go, instead of planting a 12 back here, because really, why? I would combine it with a 9, just make it 108, because 12 times 9. So then you've got plus. That's why we write things in pencil, so we can adjust the coefficients in front if we want to. Plus second. And notice I left a 3, or a space, because I know the 3 is going to be in there somewhere. Times the derivative of the first. So taking the derivative of this, you're going to pull down the 4. So now it's a 12. Then you have your quantity to the third. And now you've dealt with this. This same thing was a quantity. It wasn't just an x. So then you take the derivative of that part, which is going to be 10x plus 7. And then leave it. Please don't try and multiply everything out. You'll have wasted everyone's time. Stop. Okay? Okay, when dealing with trig functions, when the number is here, that's the first thing you deal with, but for this one, the number is back there, so it's only acting on the 3x squared plus 7. So that means that the biggest thing that's going on with this particular problem is the secant. So the derivative of the secant of something is secant tangent. And I know that this is going to get involved somewhere, and I don't like cramming it in the back. And same thing, I feel like it's awkward. So I'm going to leave some space here. So I think it's a good idea. So we've got secant, tangent. And notice when I'm writing that down, I've touched this not at all, okay? So then you're going to start dealing with this. And I'm going to put it in front because I don't like it back here. You can put it back here. It's not wrong. It just, I feel like it looks awkward unless you somehow bracket this off so that it doesn't look like it's trying to impede on the tangent part, okay? So for this part, you pull the 2 down. Then you have this to the first power, and then because this was in individual terms, take the derivative of these, okay? So derivative of this is going to be 6x, derivative of this is going to be nothing. So same thing, the 2 and the 6x are going to make friends and just be 12x. And so leaving a little bit of space meant I did not have to rewrite the problem again, which I like, because I feel like the more times you rewrite messy looking problems, the more likely you are to goof up a parenthesis or to mess something up. So I just like to be careful as I go. You want to make sure that you're really careful with your parentheses when you're doing these problems. You can put in more than you need, but if you get sloppy and you don't close them in the right places, that could easily make your problem wrong. So make sure if you open a set that you're conscious about where you're closing it so that it closes in the right place. All right, 3 more. That'll be it. One of which is super easy. Not that any of them are super terrible, but. All right, it's the same thing. You have a product, which means you're going to have to do product rule. So product rule, you've got first, derivative of second. So you're gonna pull the 1/3 down. Take the derivative of this, or no, rather recopy it. Subtract 1. Chain it, because then this is a quantity. So the derivative of this part, you're looking at 12x cubed minus 2. Okay, and now notice I opened parentheses here, close them, and now do the back half of product rule. So you got second. Derivative of first, which is just going to be 8x. And same thing, looked at the problem and realized this was going to have a super simple derivative, which was why I left a little space here. Not that you can't put it all the way in the back, but it looks weird. So if you just peek at it and fix it right off the bat, it's easier. The only thing I might do, but in all honesty, I probably wouldn't, because it would involve me maybe rewriting stuff, is I might make this 4/3 x squared. I might not. It doesn't really matter, okay? Because like I said, we're not doing anything with it right now. Okay, I'm going to do a real simple one, and then we'll do sort of ugly-ish trig one. And that'll be it. So here I put parentheses around the 6x. Doesn't need to be there. I do that about half the time. Okay, so remember, because you have the 4, you have no business doing product rule, because we don't do product rule and we have constants. That just shows that we don't know what's going on. Don't show people that, even if you don't know. Why? Okay? So, the derivative of the tangent of something is secant squared. So we've got 4 secant squared of 6x. That, same thing, is a quantity, because its derivative is not just 1, so then you have to chain it. And the derivative of 6x is 6. Don't put the 6 back here. It's weird. Combine it with the 4. 6 and 4 is 24. That's it, okay? Sometimes they're ugly problems. I feel like the ugly problems are nice in learning to mess with the concept, because it's hard to miss the fact that something else was going on, okay? But they're not all giant ugly problems. Sometimes they're pretty simple, okay? Last one. So, same thing, it's a product, that means you have to do product rule. So, product rule, you've got first, derivative of second. The derivative of cosine is a negative sign. Don't write it like that, because now it looks like a minus sign instead of a negative. That's not great. If it's negative, just put it in front. So then you've got sine of 7x minus 2, which was a quantity. So then you have a 7, which I wouldn't put back here. I would put in front. And I go, oh, well, I didn't leave space for that. So you go, thank goodness I write in pencil and or expo marker. So then you have minus 7 plus second derivative of first. So here, biggest thing that's going on is the squared, so you pull the 2 down, and then you have secant of 2x to the first, and then you have the derivative of secant, because that's the next biggest thing that's going on. The derivative of secant is secant tangent. Don't write secant 2x, tangent 2x. Weird, okay? Secant of 2x times secant of 2x is secant squared 2x, tangent of 2x. So you've dealt with this, and you say, okay, but that has a derivative of something other than 1. It's 2. So then that 2, instead of camping all the way back here and being super squish, is going to make friends with this 2 up here. So you have 4. And same thing. That's it. You could technically do some more stuff with it, but for right now, it doesn't help. Leave it alone.